Alright, you're welcome to my YouTube channel. This is Grace Tutor, and what I do here is that I solve technical drawing problems, and I also provide information that are very important that you need to know for you to have a better performance in your technical drawing examinations. And if you are new to my channel, if you are watching my video for the first time, I welcome you. And if you're a technical drawing student, I want to ask you to subscribe to my YouTube channel and also share my videos with your friends who are also technical drawing students. And don't forget to put on the notification bell so that whenever I upload a new video, you will be notified. And then I want to ask you that as you are learning here, please, you need to practice this subject. This is a practical subject, and I usually tell my students to practice this subject so that you can master it. So now, what I want to do now is that I want to solve this problem that you see here. This kind of object in mechanical engineering or in engineering, so we call this kind of object or this type of object, we call it transition piece. And what I want to do here is that I want to produce the surface development of this object that you see. I want to produce its surface development. I want to show you how you can produce the surface development of this kind of transition piece. Now, as you know, or as you might have been taught, that when we are talking about surface development of objects, there are three methods that we can use to produce the surface development of objects. The first method is parallel line method, and the parallel line method is used for the surface development of prisms and cylinders. I said parallel line method is used to develop the surface of prisms and cylinders. So the second method is known as radial line method, which is used to produce surface development of cones and pyramids. Okay, now when it comes to transition pieces such as this, we use triangulation method to produce the surface development of this kind of object. So because this object is composed of, as you can see here, it is composed of triangle, and it is also composed of a conical surface, as you can see, or a curved surface as you can see here. So now, as I said that, I'm going to show you how you can produce surface development of this bed. Let's look at the features of this object. As you can see, we have a square base. The base is in square form, 70 millimeters, AB 70 millimeters, and BC 70 millimeters, and every other side they are 70 millimeters, which means we have a square. Then we have a circular top whose diameter is 40 millimeters, and the height of this object is 60 millimeters. So then we are being told here that this is the seam line. That means the object is cut here, then we open it. Okay, so that is what we want to do. I want to produce surface development of this object, and I want you to follow me. It is simple, but you need to pay attention to what I'm going to do. Now, let's go and look at what we need to do. So the first thing that you need to do is to produce the orthographic views of the object, that is the plan and the front elevation. The plan and the front elevation. So the first thing I will do here is to draw a vertical center line. Okay. Okay, then I will produce the horizontal center line here. Then I will draw a circle of radius 20 millimeters because the diameter of the circle is 40 millimeters. So I will draw a circle of radius 20 millimeters. So I will take 20 millimeters on my ruler, and I will draw a circle like this. Okay, so I draw a circle like this. So this circle, I'm going to divide it into 12 equal parts. I divide it into 12 equal parts, as you can see here. So I'm dividing it into 12 equal parts. I believe you know how to go about that. Okay. So the last one is this. So I will put it here. I make an arc here and make an arc here. So I divided the circle into 12 equal parts. So the next thing I'm going to do is that I will take a measurement. So as we know that the square base is 70 millimeters. So I will take 35, which is half of 70. So I will take 35 with my compass, put at the center here. So I make an arc here. So make an arc here. So make an arc here and here. Then I will draw a square. So I will draw a square. So don't forget that what I'm doing first is to produce the orthographic views of the object. So I'm producing the plan now. I'm working on the plan. So from the plan, I'm going to project the front elevation. From the plan, I'm going to project the front elevation. So just follow me. It's very simple. Okay. Okay. All right. So now the division that I did on the circle, I'm going to number this point. So this point, I will call this point. This is point 1. This is point 2. This is point 3. This is point 4. This is point 5. This is point 6, point 7, point 8, point 9, point 10, and point 11. Then we have point 12. So now, as you can see that on this object, we have some divisions were done here. As you can see, I believe you can see it. So as I divided this curved part or the arc into a number of equal parts here, and then we have this line being joined to this point B, and this is also joined to this point B. I'm going to do the same thing in what I've done here. So let me first label this point on the square. So this is point A, this is point B, this is point C, and this is point D. Now, so the next thing I'm going to do is that, so I'm going to join point 1. Point 1, I will join it with point B here, and point 4, I will also join it with point B with a thick line. As you can see that those lines are thick. Then point 2 and 3, I will join them with point B with a thin line. So I'm using my red pen for that. All right, so I'm going to do the same thing for point C, point D, and point A. So while I pause the video. All right, as you can see, so I've done what I did for the first part here in the plan. So the next thing that I'm going to do is to produce the front elevation. So for the front elevation, the object is being viewed in this direction. On this side, AB here is being viewed in this direction. So I want to produce the front elevation. So to produce the front elevation, so the first thing that I'm going to do is to draw a horizontal line here, like this. Now, so the next thing I will do is to produce a vertical line from this side BC here, and then a vertical line from side AD to this horizontal line. Then I will come to this part of the circle here. On this part of the circle, that is on point 4. Then I will draw a vertical line like this. Okay, then come to point 10 here on the part of the circle. So draw a vertical line here. So the height of the object is 60 millimeters. I will take a measurement of 60 millimeters. So this is 60 millimeters. Then I will draw a horizontal line. So horizontal line, so I will make it, I need to make it a thick line. So let me make it a thick line at once. So, and then, so I'm going to join this point. I'm going to join it together with this. Then I will also join this, so together with this point. Okay, then this line also will be made a thick line. So this is it. All right, so having done this, so what we have here, so this is the same line. This is the same line, and the same line we have 1 and P here. So we have 1 here, and here we have P. This is the same line. We are cutting it from here, and we are opening from here. So this point here, this is point P, as we have in the diagram, and I will call this point, I will call it point P prime, and this point is point B prime C prime, and this is A prime D prime, and here we have point 1 here. So don't forget that this line, okay, so this will be 1 prime. So this line 1 prime, this is where we have the seam. This is where we have the seam. Now, the next thing I'm going to do is that I need to produce the true length of these lines. So I mean line 1B, line 2B, line 3B, and line 4B. So the same thing applies to all this, but if I can get the true length of line 1B, 2B, 3B, and 4B, the same thing applies to all the rest, because they are all the same. Okay, now, so to get the true length, so what I'm going to do is that if you look at this line from here to here, they are representing this line 1B is representing this line. This is what? This is where we have line 1B. And if you look at this line is longer than what we have here as 1B in the plan. Okay, so we need to look for the true length of this line 1B, 2B, 3B, and 4B. And to do that, what you need to do is that, so come to this point here with your T-square and draw horizontal line like this. Okay, then we are going to rotate this point. If you look at point 1 and 4, they are the same point on the circumference of the circle. That means if I draw an arc from point 1 here, it will pass through point 4, because they are the same distance on the circumference of the circle. Likewise, point 2 and 3. So what I mean is this. So if I put the pinpoint on my compass here, so by putting the pinpoint on my compass at this point B here, and I extend it to point 1, here, okay, and I draw an arc from here to pass through point 4, as you can see it. So it will pass through point 4 like this, and it comes here, so resting on this horizontal line. So this point here we have what? Where you have point 1 and 4. So we want to find the true length. So the next thing that we are going to do is that, so I will put at this point and extend it to point 2. So by the time I draw this arc, it will also pass through point 3. So you will see it. So there is it. So like this. So it passed through point 3. So there is it. So resting on this horizontal line. So this is point 2 and 3. Okay. So next thing I'm going to do is that, so I will need to extend this line here. I need to extend this line here a bit like this. Then from here, I will draw a vertical line from this point 1 and 4. So draw a vertical line. Okay. So this is 1 and 4. So we want to get the true length of line 1B and 4B. So now, so from this point now, I will draw a line. So draw a line from this point to this side of the front elevation. So I will draw a line from here to here. So this is the true length. So this is the true length of, so 1B and 4B. So then also I will draw a vertical line from this point where we have 2, 3. So I will draw a vertical line from here. So it goes like this. Okay, so here we have, this is 2 and this is 3. Okay, then I will draw a line from this point, so to this point here. So this is the true length of 2B, 3B. So this true length that we have gotten for 1B and 4B is also the same for 4C and 7C. Also 7D and 10D, and then 10A and 1A. So I believe it is clear to you. Okay. Now the next thing that we are going to do now is to produce the surface development of the object. Now, before we begin to produce the surface development, so you will see that this object, it is composed of 4 isosceles triangles. 4 isosceles triangles. We have 1, 2, 3 here, and the 4th one here. Then we have 4 conical surfaces. 4 conical surfaces, 1, 2, 3, and 4. Okay, so we are going to produce those 4 surfaces in conjunction with the triangles. So that is what we want to do here. So the first thing that you are going to do is that, as we have here, that the object is cut here. It is cut here. This is the seam. So we are going to produce this right angle triangle first. Then by the time we draw the rest, we end with a right angle triangle. So let's see what we are going to do here. Let's see what we are going to do here. So the first thing to do is that I'm going to draw an horizontal line here. I will extend this horizontal line. Then I will produce a vertical line. I produce a vertical line here like this. So as we have here, we have point B here. This is point P. We have point P here, and then here we have what? We have 1. So we have 1 here. So what I'm going to do is this. So I'm going to label this as point P. Then for point 1, so you take the height. So P prime 1 prime. So take this distance. So from here to here. Okay, so bring it to point P here. Bring it to point P and draw an arc here. So this is point 1 here. Then to get point B here, I'll just take this distance PB. Okay, so I will take the true length. So this true length is 1B. So which is what we have found here. This is 1 for here. So you take this true length, this distance from here to here. Okay, so bring it to point 1 here, and you make an arc on this line. So this point is point B. As you can see here, this is point B. So then I'm going to make this line, I'm going to make it a thick line like this. Then this line, I will make it a thick line from here to here. Then I will join this together to form that right angle triangle. So don't forget that we start the surface development from the seam line. Okay, so that is the first one. So the next thing that we are going to do is that, so we want to get line 2B. So you take this arc 1, 2 with your compass. This arc 1, 2 here. So take it with your compass like this. So put it at this point and draw an arc here like this. Then line 2B, we have the true length here. This is the true length. So take this distance from here to here. So put it at point B here. Put it at point B and you make an arc here. So this is the point. Then, so we join this together with a thin continuous line. Okay, so this is point 2. So this point is point 2 here. Okay, so we take note of that. So next is we want to produce line 3B. So take this arc 2B, arc 2, 3. So take this arc 2, 3, which is also the same as that of 1, 2. So put it at this point 2 here, and you make an arc here. Then take the true length of 3B. Okay, so put it at point B here and make an arc here. So this is point 3. So this is point 3. Then we draw a line. So this is line 3B. So the next one that we are going to produce is 4B. So 4B, to produce 4B, so we take this arc. So we take this arc 3, 4. So put it at this point. And then, so we draw an arc here. Then we take true length 4B, which is here. So put it at this point B here, and we make an arc here. So this is the point of intersection. So this line, we are going to make it a thick line. So make it a thick line. So this is it. Then we have a triangle here. We have an isosceles triangle here. So this isosceles triangle we are going to produce. So what you need to do is that take this distance BC. Like this. Take this distance BC and put at this point. So draw an arc here like this. Then we take the true length 4C. True length 4C, which is also the same as what we have here, which we have produced already. So take this distance like this. So then you put it at this point. So don't forget that this is 0.4. This is 0.4. So put it at this point and we make an arc here like this. So this point is point C here. So we join this together with a thick line. So we join this together with a thick line. Then we join 4C with a thick line. Okay. All right. So next is for us to produce line 5C here. Line 5C. So we take this arc 4, 5 like this. Arc 4, 5, take it like this. Then put it at this point and you draw an arc here like this. So then we take distance of the true length here. So this true length is also for 5C. So we put at this point and we draw an arc here like this. So this is 0.5. So this is 0.5. So then we join this together. So when I'm done with this, I will pause the video and do the rest. So the same thing applies to other ones. So when I'm done with this, so I will pause the video and do the rest. Then I will come back and show you the next thing that we are going to do. So now we have gotten 5C. So the next is for us to get 6C. So take this arc 5, 6. Though the arcs are the same. The arcs are the same. So the arcs are the same. So we take arc 5, 6. So we make an arc here like this. Then we take the true length. So true length, this is the true length where we have 2, 3 here. Okay, so we put it at this point. At this point, C here. So we draw an arc here. So this is 0.6. So this is 0.6. So we join this together with a thin continuous line. Okay. Then we have 7C. So 7C. So we take this arc 6, 7. Okay, so we put at this point 6 and make an arc here. Then we take the true length. So the true length now is where we have 1, 4. That is true length of 7C. So we put at point C I'll make an arc here like this. So I believe you are getting it. So this is 0.7. So we make this a thick line. So make it a thick line. So for us to get point D, so we have this is an isosceles triangle C7D. So we have to take this distance. This is the distance CD. Okay, we take this distance CD. So we bring it to this point C here, and we draw an arc here like this. Then we take the true length D7. So D7 is also the same as what we have here as 1/4. So we take this distance. So we put at this point 7 here and make an arc here. So this will be joined together with a thick line. Like this. Then I will join this together. The thick line. So this is point D. So this is point D. So I'm going to continue while I pause the video. Then when I'm done, I will come back and show you the next thing that we are going to do. So I've located point 8, 9, 10, 11, and 12. So I want to draw the last right angle triangle. Last right angle triangle, and as you know that the object is cut here, and we started with this first right angle triangle. So I want to get the last one. So I want you to see how I'm going to get the last one. That's why I come back to show you now. So what you need to do now is that, so we take the true length A1 or 1A like this. So this is it. So we take it like this. So 1A, okay, so let me take PB. Let me take PB or AP. Let me take that first. So this is it. So let me take it first. So this is it. So I put at this point. So I'll draw an arc here like this. So then, so I will take this P prime 1 prime, P prime 1 prime. So I will take it here like this. So P prime 1 prime, I will take it like this. Then I will draw an arc here. Okay, I will still need to extend this. So I need to retake this. Okay, before that, okay, sorry. I need to take this arc here to get the last point 1. So because I need to come back to 1, as I've started with 1 here, I have to come back to 1. So I have to take this arc. That's what I was looking at. So I have to take this arc here, then put at point 12 here. Put at point 12. Then I will draw an arc here like this. Now, after I've drawn the arc, so the next thing I'm going to do is to take the true length. So the true length 1A, so which is this line 1/4 that we have here. So I put at A here. Then I will draw an arc here. Okay, so we got point 1 back here. So the next thing I'm going to do is to join. So this will be a thick line now. So this line will be a thick line. Okay, so this line will be a thick line. All right, so this one I will come back to it. So all I need to do is to retake AP. Like this. So bring it to this point A here. Then, okay, so this is now, so this is point P now. So we come back to point P. Then I will join this together. So join 1P together, and then I will join AP together to form that right angle triangle. So this is it. All right, so the next thing I'm going to do is to join all these points together with the use of a French curve, so to produce the curve of the circular part of that object. So that is what I want to do now. So with the use of my French curve, so I want to join them together. So this is it. Oh. Okay. So we take it easy. So I can join all this together. Okay. Then the last part is here. So just take it easy for you to get a smooth curve. So I'm doing it here. All right, so this is the surface development of the transition piece, which is this object that you see here. So as simple as I've done it here, all you need to do is to practice, and when you practice, you master it. Just follow the procedure, follow it the way I explained it, and you will master it. Thank you for listening, and thank you for watching. God bless you.